Hope everyone's doing all right today. We're going to look at the two-pointer technique, which is a simple, powerful technique that you'll use quite a bit in coding interviews. And so what we want to start off here is a sorted array. So imagine this is a sorted array, and the problem that you'll see a lot of the times is called the two-sum. Essentially what you're looking to do is figure out the two numbers that equate to 16, right? And if you look at here, if you do find them or it's in this array, you return true, right? If it's there, it's true. If it's not there, it's false. As you can see here, if we just look at this quickly, we have multiple variations, but one of them that we'll get to here is 9 and 7. That equals 16. We can do simple math. We all know that. And then in this instance, if we want the sum of 16, that should return true. So how would we go about doing that? One of the naive ways that you could start, and what some people would do or consider as brute force, is just to go through each of these numbers twice, right? So you essentially do a nested for loop. And so you're basically trying to find, hey, with 1, I'm going to add all these up. 1 plus 2, 1 plus 4, 1 plus 6, 1 plus 7, so on, until you get to 16. And if it's there, then you return true. That is a nested loop, and because of that it becomes an O of n squared, right? Because you're basically going through every number twice within itself. Now, another approach that you might take with this two-sum array is you might use something like a hash, right? So think of it as we're going to go ahead and loop through everything one time, right? We're going to do a for loop, and then within here, let's say you have a hash that stores the sum or the difference of the other number, right? So think of it as you have 1, and as you loop through 1, you say that, hey, we have 1 in here, and what is the number I'm looking for? I'm looking for 15. So you'll store the 15 into this map, this hash map here. And if you ever loop to a 15, you'll know, hey, this is 16 together, return true. And so what will happen is this will keep going, we'll do 2, looking for 14. And if you have that, it'll go through and it will keep going until it finds 7. 7 here, it'll go and find 9. And at this point, we don't have 9 in the map yet. The next number in array 0, 1, 2, in the 5th element here, we'll go ahead and we'll see 9. And at 9, we'll be like, hey, this is in the hash. So let's return true, right? So this is another way you can go about doing it. The problem here is you are storing a little bit more data in memory. So although this is a O of n solution, in theory, you're only going through it once. In terms of speed, right? In terms of the speed complexity, the actual amount of data you're storing could be higher. So the data complexity here is pretty much O of n as well. Or in the worst case scenario, it's O of n. You're basically storing everything at least once until the end. So now that we were reset, another way you could think about this is using 2 pointers. And that's sort of the idea of this technique, is having a pointer here at the beginning. Let's say we have a pointer I, right? And then we have a pointer at the end here, let's say j. And what you can do is, because it is a sorted array, the value and how much the total sum is at this point. So this we know is 18, right? And then what will happen is, if it's greater than our target, what we're going to do is we're going to shift to the left from the rightmost. So we know we're going to go ahead and shift here. So now we're going to check 11 and 1, and we know this as being 12. And because it's lower than 16, we're going to go ahead and keep shifting to the right now of I. So this is I++, right? And it'll go 2 and 11. And basically we'll keep doing that until we hit 7 and 9. And once again, because it's a sorted array, we know that the left side will always be less than and the right side will always be greater than. And then we can continue collapsing this array. This is essentially an O of n solution, which means you're only going through it once, max. And on top of that, you are only storing 2 pointers, an I and a j, right? And because of that, you don't have this overhead of storing n number of values into a hash map or some other data structure. So how does this look in terms of the actual code itself? So the easiest way to tackle this would be a while loop of some sort. So assume we have toSum as a function here, and we have an array. Let's just call it A, right? Within here, we want to define the two indexes that we're going to start with, the 2 pointers. We're going to have an I and a J. And then based on what we see as the sum, whether it's greater or less than, we're going to go ahead and increment one or the other. This will return a Boolean of some sort. We're going to go ahead and do a while loop. So we're going to initiate, let I equal to 0. So let's start index. J is going to be the length or the last index of this array. And then while they don't equal, we're going to go ahead and check, right? We're going to see what the values are. So if the array at I, we're going to just do the base case here, right? Equals a sum or whatever we're looking for. Then we're going to return true because this is the true case. If it is less than, then we're going to go ahead and increment I. So let's go ahead and just really quickly do this. So assuming I, we're going to start with 1 and 17, and that's going to be greater than, right? If it's 1 and 11, so that's 12, we're going to go ahead and increment the left side, which is the I here. So we're going to go ahead and increment I here. And finally, if we have something that is less than, I'm going to actually just copy everything that we have here. Greater than the sum, then we're actually going to decrement J and make sure we keep the right pointer going into the middle. And of course, at the end of all this, if we don't find any match, so we get, basically I and J come up all the way and meet at one of the indexes, let's say 9, we're going to go ahead and return. Right, so this is essentially using the 2-pointer technique with toSum and having the ability to then go ahead and iterate through an array with 0 or O of n time and essentially O of 1 when it comes to the data complexity or the storage. Hope you guys enjoy, and I'm going to have a little bit more to show about how we can utilize 2-pointers for a bunch of other types of problems. This is just a core concept and something you need to understand before you move on further, but there are a lot more intricate and harder questions to go into, so we'll go ahead and do those next.